Hi guys, it's Mrs. Seitz. Today what you're going to be learning is what a conditional statement is as we begin our second unit in geometry. So by the end of today's lesson, you're going to be able to recognize and analyze conditional statements. So the first blank that we're going to be filling in right here, and again, you can be filling this in if you wish on your own piece of paper, or if you want to, I can give you a note taker for you guys to fill out as well. But the first blank here is a conditional statement. So you're going to hear that word a lot. So a conditional statement is a logical statement that is going to be written in the form if and then. So here's an example. So if x minus 4 is equal to 5, then x is equal to 9. So there's always going to be an if in the problem, and then there's always going to be a then. The if part actually has a special name for it. It's called a hypothesis. And the ending part, so the after the part that follows the word then, so like in this part, the x equals 9 part is called the conclusion. So if I look at my first conditional statement that I just showed you guys, if x minus 4 equals 5, then x equals 9. X minus 4 equals 5 was my hypothesis. Then x equals 9. X equals 9 was my conclusion. And another example, this one is not involving math. So these conditional statements don't just have to be about math, they can be about anything. If it's noon in Georgia, then it's 9 a.m. in California. So following the word if it's noon in Georgia, so the hypothesis, then it is 9 a.m. in California. So it is 9 a.m. in California would be the conclusion. So just so you know where this is all headed, this is all starting with our logic unit. So this is all starting for us to determine just based on logic, using true and false, using if and then statements, hypotheses, and conclusions. And we're all going to be getting ready for proof. So this is baby steps into what a proof is. All right. So take a look. We're going to first rewrite rewrite the conditional statements into if then form. So it says 2 points are collinear if they lie on the same plane. Well, I first want to find if there's some kind of phrase that's following the word if, and that would be identified as my hypothesis, if it's possible. So let's see here. I see the word if, and it says if they lie on the same plane, then there's 2 points that are collinear. So maybe I can kind of rephrase that. So for the first part, I'll say maybe this part here is our hypothesis because it's following the word if. So I'll say this is our hypothesis. So I'm going to say if, and instead of say they, okay, so we'll say if 2 points lie on the same line, then the 2 points are collinear. And again, I'm not asking you to determine if it's true or false. All I'm asking you to do is to rewrite the conditional statement in if then form. So if you can identify what the hypothesis is, if there is an if in the problem, whatever follows the word if is the starting point of the if then form. So let's take a look at the next one. For part B, it says all sharks have boneless skeletons. So I'm not quite sure that I see the word if here. So let's think about this one. How about we say if there is a shark, then it has a boneless skeleton. So again, that one didn't have the if in the front. So I'm assuming that the hypothesis would be that we're starting with a shark to begin with. So if we're starting with a shark, then I'm assuming that the conclusion would be that it would have a boneless skeleton. So let's take a look at part C. A number is divisible by 9 is also divisible by 3. Okay, so I don't see the word if in the problem, so I don't have to worry about like starting with something to have the hypothesis. So maybe we can just assume the beginning part is the hypothesis. So I'm going to say if a number is divisible by 9, then it is also divisible by 3. And again, I'm not determining if this is true or false. All I'm doing it is writing this as if and thens. All right. So these are all, again, called conditional statements because they can all be written in the form if and then. A conditional statement can be true or false. So going back to these statements here, if 2 points lie on the same line, then the 2 points are collinear. Well, that would probably be a true statement, right? If I have 2 points that are falling on the same line, we learned by definition before that that means that you would have something that is collinear. So that would be something that would be considered a true statement. But you could have things that are also false as well. To prove something that is, or to prove that a conditional statement is true, it has to work for every single case. So all cases must be true. To prove that a statement is false, you only need one counterexample. And we talked about that a little bit before when we talked about some logic in chapter 1 and we were talking about some reasoning with patterns, but you only need one counterexample to prove something false. And that still applies in our logic unit when we begin some baby steps into proof as well. So let's keep practicing that. We're going to write a counterexample to show that the following conditional statement is false. So again, we're applying some of the vocabulary. We're still practicing what we know what a counterexample is. Remember, a counterexample is that one statement or one example that will prove a statement false. And remember, a conditional statement is just something that is using the phrases if and then. So if we're starting out that x squared is equal to 16, so we're going to assume that x squared is equal to 16. We're going to assume that that starting point is true. What we're going to try and prove right now is that this x squared equals 4 is not true. We're going to somehow try to disprove this part. So can we come up with some kind of way to prove that there's some other answer out there besides x equals 4? Well, if we think about this, and you might remember this from algebra, when you have a square here, that's actually saying that you could have two potential answers here. So we learned before that if you square root both sides, you're going to have an answer of positive 4. So that really doesn't prove our case, right? But aren't there actually two numbers that when you multiply it by itself, that it'll get you positive 16? I know 4 times 4 gets me 16, but wait a second. What if I did this? There's another root out there that's going to work as well. This is just the positive root. What about the negative root? If I do the quantity of negative 4 squared, don't I also get 16? Yep. So This would be our counterexample. So our counterexample for this statement that proves this wrong is that x could also be equal to -4, okay? Because -4 times -4 also equals 16. So to again prove to get a counterexample, you're starting with the assumption that the hypothesis is true, and you're finding a way or another example to prove that the conclusion is false. So in this problem, I started out by assuming that the hypothesis was true. So I was going with x squared equals 16 is true. And then I went off of that to show that there was another counterexample out there of x equals -4. All right, so now that we have and remembered what counterexamples are, we're going to be talking about different ways that we can move conditional statements around, and this can help us in the future for proof as part of logical reasoning. So again, this can help us to again get from point A to point B whenever we begin whatever an algebraic or a geometrical proof could be. And this is all from sound logical reasoning. So we're going to be learning some new vocabulary. So here's one of them. Okay, a part of a conditional statement that switches the hypothesis and the conclusion in a conditional statement is called the converse. And that's why I have a picture of a Converse tennis shoe there for you as well to help you to remember it. Okay, the reason why I also have a picture of a flip flop here is because what happens is you basically take the hypothesis and the conclusion and you flip flop them around. Okay, so if we start out with if x minus 4 equals 5, and we end up with x equals 9 as our conditional statement or our CE, if I asked you to find the converse of that statement, you're flip flopping your hypothesis and your conclusion around. So the converse of the statement would be instead of starting with x minus 4 equals 5, we start out with if x equals 9, then x minus 4 equals 5. So I flip flopped it around. Another type of logical item that we can perform on any type of conditional statement is called negation. And this is our next vocabulary word. A statement can be altered by negation. That is by writing the negative of the statement. So let's say a statement is the measure of angle A is equal to 30 degrees. The negation would be the measure of angle A is not equal to 30 degrees. Another example, if the angle A is acute, then angle A is not acute would be the negation of it. Two different types of forms of conditional statements that use negation. One is called the inverse, and another is called the contrapositive. An inverse negates or takes the opposite of the hypothesis and the conclusion of the conditional statement. So, again, if we go back to our original statement, and I'm just going to rewrite it, our original statement was if x minus 4 equals 5, then x equals 9. This was our original conditional statement. If I'm asking you to negate the hypothesis, which the hypothesis is x minus 4 equals 5, if we negate it, it would be x minus 4 doesn't equal 5. If I ask you to negate the conclusion, x can't equal 9. They're staying in that same order, but they're negated. So if that happens, that is called an inverse. If I take the negation of the converse, remember what the converse is? The flip-flop, right? So if I completely flip-flop these things around and negate them, so the flip-flop was, or converse, right? If x equals 9, then x minus 4 equals 5, right? This was the converse, right? If I ask for the contrapositive, I want you to negate these statements. So then what you're going to do is you take the opposite. So if x doesn't equal 9, then x minus 4 doesn't equal 5. Okay, so contrapositive messes everything around. It flip-flops things around and it negates as well. What we're going to do right now is we're going to practice writing an inverse, a converse, and a contrapositive of a conditional statement. In logical reasoning, you're going to see abbreviations for a hypothesis and a conclusion. Anytime that they abbreviate a hypothesis, they're going to use a P for hypothesis and a Q for conclusion. All right, so here we go. Here is the statement. If 3 points are collinear, so this would be our hypothesis. So I'm going to put a P above that because that's our hypothesis. Then they lie on the same line. This is our conclusion. All right. We have to write an inverse, a converse, and a contrapositive. Okay, well, the abbreviation C stands here for a converse. I'm just going to write that out. Remember, converse, we think of the tennis shoe, right? And when I think of shoes, I think of flip-flops, right? So remember what a flip-flop does. It takes the hypothesis and the conclusion and it flip-flops them around, right? So instead of it being the hypothesis first and then the conclusion, it takes them and it flip-flops them around. So how am I going to write that? I'm going to write it as if. Now I can't just say if they lie on the same line. So instead I'm going to say if 3 points lie, or how could I say if 3 points are collinear? I can't say that. If 3 points lie on the same line, because we have to use that. Then they are collinear. Okay, so again, you're starting with the conclusion and ending up with the hypothesis. You're flip-flopping around. All right, now think about what the inverse does. The inverse keeps the hypothesis and the conclusion in the same spot, but it just negates them. Okay, so there I go. I'll use red for that negation. If 3 points are not collinear, then they do not lie on the same line. Okay, and again, that was the inverse, where you just keep the hypothesis in the same spot and the conclusion in the same spot, and all you do is negate them. Okay, now the last one is the contrapositive. I'm going to write the contrapositive up top because I don't think I'm going to have enough room for it, where I have it right here down at the bottom. So I'm going to write the contrapositive up here. Remember what the contrapositive does. The contrapositive flip-flops everything around, but then it negates it. So I'm going to look at my statement that I have here for the converse, and I'm pretty much going to keep that, but just throw in some negation with it. So I'm going to write if 3 points do not lie on the same line, then they are not collinear. So again, remember the contrapositive flip-flops things around and negates. All right, let's try another one. All right, so the conditional statement is if it is cold out, then it will snow. All right, so the converse, so I'm flip-flopping. Okay, so here is the hypothesis. And here is the conclusion. All right, so flip-flop this around. So instead of it being if it is cold out, then it will snow, I'm going to say if it will snow, then it is cold. All right. Now, I didn't ask you if these things were true or false yet, but let's think about them. So look at your first statement. If it's cold out, then it will snow. Is that true or false? That one might be false, right? Because there's been plenty of times I know that it's been cold out, but it doesn't actually snow, right? But think about the converse. This converse, the flip flop, that one's true, right? Because I know if it's snowing, it sure as heck is cold. It has never been warm out when it's been snowing. So that one definitely is true. All right, let's go down to the inverse and then we'll think about if the statement is true or false. All right, inverse, remember you keep everything in the same order as the original statement, you just negate them. So if it is not cold out, then it will not snow. Okay, so if it's not cold out, then it's not going to snow. All right, that one's probably true, right? So if it's not cold out, okay, it's probably a little bit warmer, right? So it's probably not going to snow. So I would agree that that one's probably true. All right, now let's go with the contrapositive. Remember what the contrapositive does? It flip-flops things around and it negates. So I'm going to look at my flip-flop, which is the converse, right? Remember, think of shoes. All right, so if it will not snow, then it is not cold. If it will not snow, then it is not cold. I don't think that that one's true because even though it might not be snowing, it could be definitely cold. All right. So, again, conditional statements could be true or false depending on if you have what type of order and if it's negated in. All right. So, let's try the next one. You might want to even pause the video and try them out on your own to see how you do with this. All right, so let's take a look at their next one. It says if x squared is equal to 9, then x is equal to 3. So let's take a look at your hypothesis. Your hypothesis is x squared equals 9. Your conclusion is x equals 3. Okay, converse time, flip-flop it. If x equals 3, then x squared equals 9. There's your converse. So let's see if that one's true. If x is 3, then x squared is 9. Yep, that one works. But we know the conditional statement could be false, right? Because if x squared equals 9, x could equal 3, that's false because it could be x equals negative 3 also. All right, let's go inverse. Inverse means you basically keep the statement in order, you just negate. So if x squared doesn't equal 9, then x doesn't equal 3. All right, so if x squared doesn't equal 9, then x doesn't equal 3. Sure. All right, let's go with the contrapositive. So that means we're going to go up to the flip-flop, the converse, right? Where you flip-flopped everything around, and then you're going to negate it. So here we go. So if x doesn't equal 3, then x squared doesn't equal 9. Alrighty. So again, you can see the difference. Some of the statements are true, some of the statements are false. All right, last one for you guys to us to try together, and then I would like you guys to move on to the next activity and try some of these things on your own. So, if angle A is supplement to angle B, then they are adjacent. So, hypothesis is angle A is supplement to angle B. Conclusion, they are adjacent. Okay, converse flip-flops, right? If the angles are adjacent, then angle A and angle B are supplementary. So I just kind of changed the words around, but really nothing has changed in terms of, what was happening in the problem. I just flip-flopped the uh, hypothesis and the conclusion. All right, now I'm going to negate. If angle A is not supplementary to angle B, then they are not adjacent. So there is your inverse. And then finally your contrapositive. So again, take your converse, your flip-flop, and negate it. So if the angles are not adjacent, then angle A and angle B are not supplementary. All right. So guys, again, what you learned in this intro to logic unit, or pretty much this lesson, was what an inverse, a converse, and a contrapositive was, like in a conditional statement. Remember, a conditional statement is just a statement that can be written as something that's positive or false, right? And I'm going to go to that right now. Okay, let me go back. So, conditional statements can be true or false, right? It takes just one counterexample to prove something false. It can be written, though, as something true and for all cases, okay? The front part is called the hypothesis, and the ending part is called the conclusion. The special parts of the conditional statements, the converse, remember the flip-flop, is whenever you take your statement and you basically flip-flop the hypothesis and the conclusion around. Negation is used in an inverse. Remember when you just make things the negative or the opposite, right? So when we have an inverse, and I will show you that last one. I know I was just talking and that last one didn't come up, but if you have an inverse like we did in that last one, you're basically just taking the original statement and you're just using the words like not or the negatives of them, but you have the original of the hypothesis and the conclusion. Finally, the contrapositive is where everything is flip-flopped around, right? You have your hypothesis and your conclusion in different spots, but then you have the negations of them as well. And the whole point in doing this is to get you guys ready with a solid foundation of logic so that you're able to start building some sound reasoning so that we could start building some geometrical proofs in the future. So, we're going to start practicing some of this stuff very shortly, but hopefully you're doing okay with this. But if you have any questions, please let me know.